Ever since I found out, more or less by coincidence, uh, how close we may be to losing all the sea ice in the Arctic in summer and winter, I've been fascinated with the task of trying to do the math and try and present that data in an understandable manner to you people out there. So this is my latest attempt to do that. And because it's the first time you see this graph, I will try to explain in some detail. So the first thing I've done here is the y-axis is called the year of no ice. And when I say year, that is significant. I'm not talking about a day or a week or a month or a half year. I'm talking about a whole year of no ice. And the ice I'm talking about is sea ice, specifically in the Arctic. um, so, because all indicators are pointing to the next decade, this y-axis only covers the 2020s, which is also fascinating from a graphing point of view. Right. So, the headline is Winter Blue Ocean estimated time of arrival with linear 6 to 24 month trends. So we're looking at when we will have the winter blue ocean, of course, like 22 or maybe 2025. And the basis for making those projections is the half year, 1 year, and 2 year monthly trends or monthly loss, half yearly and yearly and 2 yearly sea ice volume losses. And these losses are then just assumed to carry on into the future in a linear fashion. That is to say, in a non-exponential fashion. So, as I mentioned in the previous clip, we cannot know if the collapse will be faster or slower than linear, but in any case, linear is some kind of default way to present it, because then at least you have one point where it can go faster or slower. So what you also have here is the months of this year: January, February, March 2017. So this is how the projection for winter ice free is developing as we get more data and as the 24-month average is changed into this year, extended. You know, the 6-month average is extended to 1st of March. It's a different 6 months than it was the start of January. So that's why you get slightly different results. And so at the start of March, the 1 year, the 12-month average, it gives you the winter ice free in 2025. That is the rate of collapse over the past 12 months now. That is to say March 2016 to March 2017. And in brackets you have the other two period basis for this same plot. That is the half year and the 2 year average. So that's about it. I should perhaps add that according to the most famous sea ice blogger on this planet, Neven Curlin, the arrival of the Winter Blue Ocean event coincides with the loss of industrial civilization. So that means you get no more bacon in the shop. You don't get any food in the shop. You don't get drinking water in the tap. So you will have to arrange for yourself in a different manner. Find your food or win the lottery or something. Okay. Bye. So, just to show you how dynamic this plot is, nothing here is carved in stone. Since last week, the half-year loss of sea ice volume has gone from 780 cubic kilometers to 750 cubic kilometers. We are losing ice volume a bit slower, so the 6-month trend points instead to 2024, not 23. So in itself, this delay of 1 year would be bad for the planet, because even more plants and animals would go extinct before civilization collapses. And we can't really afford to lose even one single species. But most humans only seem to worry about their own. So, but both of these, or all of these three projections for loss of winter sea ice, 2024 and 2025, for 25 for the 12 month and 24 for the half year and 2 year. All of these are based on linear collapse of sea ice volume, and as some of you may know, there are good reasons to believe that the final collapse of the Arctic sea ice will be very much exponential, with all the feedbacks acting together and just crashing the old ice and you know, making it go away much faster than even this estimate. So there is hope.